Okay, now this is on the space station, and they are spinning water in microgravity. There's no gravity here to speak of. So what will happen to that water when it spins in this condition? Now, and this is on the space station, it's in space. I know the flat earth people are going to attack this, and please don't do it, because I'm going to remove you. So I have to tell you that. It's just argumentative at this point. All right, so here we go.
Here we have a rotating sphere of water about 25 millimeters in diameter, and inside this sphere are a whole bunch of little tiny air bubbles. And we will see what the angular acceleration due to rotation does to these air bubbles as a function of time.
All right, he's got, they call it a surfactant in there to keep these things structured in bubbles. Now, obviously, they would not stay in bubbles like that, and they would have a complete cavitation instead of all this little cylindrical looking stuff.
What you're observing are the bubbles moving to the center axis of rotation. As a function of time, they will form this rather tightly packed bubble core. These bubbles are kept from coalescing from a small amount of added surfactant to the water.
Now, something I want to mention is he's spinning this thing like crazy compared to what the Earth is spinning. The Earth can make one rotation in 24 hours. So he's got the faster it spins, the tighter the core is going to get. That's my point.
Here we have a rotating sphere filled with bubbles and tea leaves, and as expected, the bubbles go to the center and the tea leaves go to the outside edge, along with a few chunks of orange peel.
All right, that's all we need to really see. This, as far as I'm concerned, that's demonstrative of what we live on, the Earth. And I believe the Earth and all planets and all moons are hollow. And the reason I believe that is from the research that was done, not by me, but by the big shot scientists that say the density of Earth and the density of all other spheres in space is virtually the same. And therefore, because Earth is solid, everything else is solid. Well, that's not the case. If Earth is hollow, everything else is hollow. So it's one or the other. That's what they say. I'm going the other. All right, this is a mud fossil bone, and it's all fractured up. Inside here, there's still some oil left. Bones turn into oil. They're a very good source of oil, hydrocarbons. Now, you see all these little holes and pores and all these different things in here. We're going to look at this in a microscope. But I am saying that these are exactly the same thing you see on the moon. And like over there, the far side of the moon. That's what we're going to be looking at, because I believe that's where we're going to find our most interesting feature that indicates a biology. So let's take a look at something else. Alright, so this is the dead center of that bone, and you see all these little tiny pores here? That's where blood was. Now blood turns into hydrocarbons, alright, which is oils, and then it turns into coal. Now, I'm going to move this out. This is right dead center in the middle of the bone. I'm going to move it out, and it'll start to come away from this black, and it'll get a little less, and then bam, there's the border right there. This thing has deteriorated, and all of the oil has leaked out right to there. All right, watch. If I go further out, it's gone. See, I can go down that whole ridge, and it's basically gone as I get out here further. This is all biology. There's some more. You know, that's still got some oily substances, the hydrocarbons. But as you get further and further out, it turns into this stuff here, where all this stuff is leaked out. You see it? There's nothing but holes. Now, that's a bone foramen. Right? You see that? those are where the veins and arteries come up and the nerves come. These are bone foramens all over this thing, bazillions of them. And guess where else they are? They are on the moon. These exact same little structures like this. They're all over the moon too. All right, this is the outside of the bone. You see this? That is the very outside of the bone. It's the exact same stuff you see on every planet, you know, every moon. They got all these little holes, and you see all that white fibery looking stuff? That is the collagens, the keratins, the fibers of life, and these are all the holes that service that biology. I mean, and that's what's on the moon, and that's what's on all these different moons. So that's what I'm showing you. Okay, my friends, Roger, Mudfossil University. Today, a stunning revelation. Jan Lamprecht from a Nexus conference 2003, 16 years ago, talking about this.
I'm interested in the hollow earth theory. Back in the 1970s, two scientists from the Soviet Academy of Sciences proposed a theory that the moon might be hollow. An American author by the name of Don Wilson then wrote a book based on this idea. It was called Our Mysterious Spaceship Moon. One of the more interesting things mentioned in that book was the Apollo 12 seismic experiment. Apollo 12 placed the first seismometer on an alien world. NASA did not expect many moonquakes. They expected the moon to be seismically dead.
The reason they put the seismometer on there was to see if there was any activity, like he said, moonquakes, volcanoes, that kind of things, little tickles in the surface. And then they did this.
To ensure some kind of seismic results, they deliberately crashed part of a rocket into the moon. When they did this, the results astounded them. The moon's behavior was quite unexpected. It rang like a bell for almost an hour.
Okay, I am a material scientist. I understand material pretty well. And when something rings and vibrates and oscillates and fluctuates its structure for an hour, there is very, very, very little possibility that can do that as a solid structure. Virtually impossible. And they know that. So what do?
Quotes from the scientists of the time are quite interesting. Science News, in its 1970 yearbook, went on to suggest that maybe the moon is hollow. It stated the following: during the first day or two after the event, many researchers were reluctant even to try to devise a lunar model that would fit the strange phenomenon. Some such models would have made for a rather bizarre moon, such as a hollow titanium ball, said Captain.
Okay, hollow titanium ball. Very, very interesting. A very solid, hard, structural outer core and nothing in the center. Very interesting. I wonder what you would do with something like that. Could that be biology? Oop, let's take a look and see. I think maybe it is. Alright, this is a tendon enthesis. It's a ball, and that locks into tissues in the body, and that strap goes out to, normally to, muscle and so forth. And then, and what it does is it can pull against bones, and it's locked into that bone, just like something like this. Alright, that ball would be inside of a cavity like that. the bone would pull against a muscle or a tendon or whatever it was, and that's the anchor spot. And I'm going to show you a lot of this in a minute. But that's a mud fossil bone. Now, the mud fossils are exactly what it was when it was a bone. There is no, all the outside coatings are on there, all of the articulations, the cartilage and all that stuff. And the only last bit of bone is right there. Right, that's the last taste of bone that's in this thing. And what happens is the bone turns to hydrocarbons inside where you got all the bloody matrix in the marrow. And I'm going to show you that on this big one down here. I got a big one right here. That's the outside of it, and I'm going to show you why I say this is very similar to what you can see on the moon, and that's the broken internal part of it in the center. That's the absolute center of that bone, and I'll show you that in a microscope because that is extremely interesting. Now, there's something else I want to show you here, which is this bone, this rock, which is not a rock, it is the head of a goose. And you say, oh, that's just a rock. No, it isn't. A rock does not have feathers. See that feather pattern? That's the pattern of feathers on a goose's head. And his little beak and his eye and all that stuff, and they get all that wrinkly stuff. Now that's where his throat is. Now, if I put a little water on that, you might be able to see it better. But that's where his throat is. See that central core there? And then right up at the top is where his neck goes. And that's what makes his head be able to go around. Now, this, go get your anatomist. This is an apical tuft. What does that mean, Roger? Well, it sits right on the tip of a finger. And all the little tendon balls come around and they lock into these holes. These are the holes of tendon balls that they invest into there. And then your finger can do all this kind of stuff. And that's a ball right there. That's the last ball that's left on the very tip. And these are on the end of fingertips. Phalanges, if you are a doctor. Alright, so don't forget now, this is this wrinkly looking stuff that is like the bone I just showed you. This is where you have some kind of nutritional investment or blood or whatever it is, blood coming in and coming back. Because every bit of you has to be serviced with some kind of nutritional value. Some things are much less required for nutrition. These things, when they set up, they're pretty set up forever. And there's very little extra changes and nutrition going on inside these things. They're rocks, literally inside your body. They are just rocks. Now, and I'm not kidding you, this is limestone. This is a CaCO3 in the end. However, inside these stone balls, I believe that's where you find chert and flint and all that really, really, crystallized sort of, really heavy-duty, hard stuff. They used to, you know what flint is. He's as tough as flint. That's what it is. It's tough stuff. I don't know if I showed you that before, but that is what this would fit right into. And then the other side would go into another bone, a ball right here on another bone, and then these two could work together and never come apart. And I mean, they are tough, tough, tough as hell. And that's, I think you can see how that works. Now this is one that has the double attachment. Sometimes you find them with just one attachment. Now this, and it might just be that the whole cap comes off at once, but some of them there's just a very, very central core, and some of them have two. Can't explain that specifically, but I believe it's due to a different location in the anatomy. In other words, one might be in the shoulder and one might be in some of the stomach straps, because I'm going to show you the mats that you have in addition to the fibers that come up well, I'll show you to you. Alright, just so you understand the anatomy here, here's the way it works. This is what they call ligaments. They go between bone to bone. I think we talked about that. Then you have bones reaching out to muscles and tendons, and that's this style. And there's a zillion little balls, a bazillion of them, and then all of these little fibers go. Now the fibers are much less tenuous than the balls. These suckers are they're everywhere, all around the world, everywhere. See, these are the colors of blood, these reds and blacks and rust-looking colors. That's blood, FeO2, FeO3, the black and the red and the yellows in between. And lichen and moss loves blood. It just loves it. Now, what are these? Those are those tendon balls. This is more than likely skin, because these are what they call interstitium. And the balls lay all over the skin just below the surface, and that's what allows it to return. You know, when you're younger, mine doesn't return so good now, but when you're younger, that stuff brings all your skin back to where it originally was. You can, and it comes right back. My claim is that all of these hex fibers, it had nothing to do with volcanism. And you see these little wrinkles here? That's the wrinkle zone of tendons. That's a de-stressed tendon. That's a stress tendon. This is on Mars. Identical, because Mars is identical to Earth, only it's dead now. You see that? How cool is that? Now, what do you think that is? Remember I told you there's straps and there's balls, and then there is interstitium where there's skin. It can stretch and then come back. Well, guess what? That is exactly what you are witnessing. This is gathered skin. This is stretched skin. This is eroded skin. This is on Mars. It's called the Mars Morse code. This underneath is literally flesh that is abraded from a dusty abrasion of like sandblasting it over the course of time. And the straps very, 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 very rarely survive. You normally end up with just the balls. But it appears there might have been a cavity here that just gave it enough so that we could see it. But you can see the gathering effect and the stretching effect. That's skin. That's Mars. This is the Mars crab. That crab is an artery. An artery has little blood vessels that go off to service the tissues. That is the vein. The vein does not have those little arterial networks. That sucks the blood continuously right back up to the heart. This pumps blood down into the tissues. These are the tissues it was supplying. Down below is the red, dusty, bloody erosion from between the layers of tissue. All right, there's one of the balls, the same thing. The strap would come up under here. You can sort of see it underneath there. But that's how they break across that line. Or maybe the line stays, like in Iapetus. Yeah, see, there's the Iapetus line. And here is all of these little things that are all over Iapetus. Those aren't impacts. And if you know how to look at them, and you could tell they're not impacts. They're just perfectly round little craters. And then you can actually see all of the anatomy. If anybody looked at it with knowing anything about anatomy and biology, they fully understand this. Not something you can question. And there's Iapetus again. There's the equatorial ridge, which is what I showed on some of those other tendon balls. And there's a tendon ball attachment. There's another Saturn moon, Tessis. What does that look like to you? What does all that stuff look like to you? Here's Mimas, another Saturn moon. What does that look like? What does all that stuff look like? It looks like the same thing we have on our moon, and I bet you those babies are ring like a ball or like a bell too. And everything in the universe that they can see has the same consistency as our Earth and our moon, and that moon rang like a bell, and I think our Earth would ring like a bell too if we could ring it. And I think that'll ring like a bell, and I think every other thing that we know of will ring like a bell, because I think they're all hollow as well. Because it's one way or the other is what they said.